Okay, so today for our Unit 6, Lesson 2, we're going to look at some strategies for solving polynomial equations. So I'm going to walk you through one example, and through one example, by using a graph, by using a table value, and by factoring, you're able to find out the answer to a polynomial equation, or you're able to solve a polynomial equation, okay? So we need to remember some of our factoring strategies today. So we're just going to use our simple trinomial factoring, okay? So I'll do a little refresh of that on the next slide. Okay, so I would write out this example and then write out or copy out the different ways that you are able to solve that polynomial equation, okay? So this is our polynomial equation today that we're looking at. So x cubed plus 2x squared minus 3x equals 0. Describe a strategy that you can apply to solve the polynomial equation algebraically. So that is essentially, I'm going to show you through B, which is using that strategy to solve the polynomial equation. So remember that when it wants you to solve the polynomial equation algebraically, it wants you to solve for x. And by x, it wants you to solve for all values of x. Okay, so we have x cubed plus 2x squared minus 3x equals 0. I'm not sure how else you would do it other than factoring, okay? But you're going to have to apply two types of factoring here. So right now, you would not know how to factor a x cubed function, okay? But because we have x cubed, 2x squared, and we have an x, we actually have a common factor. Remember, a common factor, you're looking for numbers that can be pulled out. So you have a 1, a 2, and a negative 3. Well, we could pull out a 1, but it wouldn't change any of our values. But from our variables x, we have an x cubed, an x squared, and an x. We'll pull out that lowest term there, which is x. So that becomes your common factor. And then you can figure out what is left over in the brackets. So remember, you divide each of those terms by x. What's left over from x cubed divided by x? Well, x squared. 2 is left over because you're not dividing by another number. X squared divided by x is x, and then negative 3x divided by x is just negative 3. Okay, so you have a factor, common factor of x. You don't actually have to write it. I was just showing you that that's your common factor. You don't have to actually write it in a bracket. Or a box. Sorry, I'll take that away from that. Okay, and then you are going to have to still figure out. We still don't know what x is equal to here. We are going to have to simple trinomial factor. I hope that you remember how to do this and that this is not brand new teaching to you. Okay, so remember, with simple trinomial factoring, you're looking for two numbers that multiply to the last number, which is your C, and add to the middle number, which is B. This would technically be A here. Okay, so two numbers that multiply to C and add to B. Okay, so we're looking for two numbers that multiply to negative 3. Okay, and then we're going to want to add them to B. So you're going to look at your multiples of negative 3. Well, you either have 1 and negative 3, or you have negative 1 and positive 3. Remember, you have your different signs there. Okay, then you need to figure out which ones, if you add them, add to positive 2. So we want a positive 2 there. Okay, so 1 plus negative 3 is negative 2, but negative 1 plus 3 is positive 2. So your two factors there are negative 1 and positive 3. Okay, it does matter the sign that you put them in, but it doesn't matter the order. So you can write x minus 1 first or x plus 3 first. It doesn't matter when you're putting it back into the equation. So keep your x there. You have to keep that common factor. But then this is broken down into x squared plus 2x minus 3x is broken down into your two factors. So x minus 1 and then x plus 3. Again, you could do it x plus 3 here and x minus 1 there. Doesn't matter, but you have to keep the negative with the 1 and the positive with the 3. Okay, so you're almost done, but not quite. You have to make sure that you are actually solving it. To solve it means come up with the values of x. Okay, so from your equation, if you were to set each of these terms equal to 0, those gives you your answer. So you have x is equal to 0, x minus 1 is equal to 0, and x plus 3 is equal to 0. Okay, but of course we want x by itself. So this one is good, because so x is going to equal 0. There's one of your answers because x is already by itself. However, we don't like this one. We have to change this. We're going to go x is equal to, just bring this term over to the other side. X is equal to 0 plus 1. So x is equal to 1. Okay, and then again, we don't like this one, so we're going to bring the 3 over to the other side just by subtracting it. So you're going to get 0 minus 3. So x is equal to negative 3. So you get your three answers, 0, 1, and negative 3. So you could do, therefore, x is equal to negative 3, 0, and 1 for x cubed plus 2x squared minus 3x equals 0. Okay, so I just listed those in order from least to greatest. Okay, so there's your answers there. And we're going to look at different strategies that we could use to do this. Your easiest one is always, and you're going to see the most in your homework, is factoring. It's usually your quickest, especially if you don't have access to technology. Okay, so, oops. We don't like that. Sorry, I didn't realize that that came up on the screen. Okay, so writing the correspond polynomial function for the equation, just remember, because it's asking for a polynomial function, that just means putting it in function notation. And then that would help you with graphing in Desmos. Okay, so if I were to put that equation into Desmos, which I did, and you can as well, you are able to see nice polynomial equation. You could tell me that it is root 3 because it has two turning, not root 3, sorry, degree 3 because it has two turning points. You could tell me how many x-intercepts. Yeah, remember last unit. Okay. Using the graphic calculator, graph the polynomial function from part C. Determine your x-intercepts or zeros of the polynomial function. So same thing, we factored that equation. We came up with our x-intercepts or our zeros or our x's. Okay, by looking at this graph here, you can see that you have a x-intercept at negative 3, at 0, and at 1. These are the same as factoring. Okay, so you are able to see that you can come up with the x-intercepts or zeros of that polynomial function also by looking at a graph. Okay, as well as if you put the table of values in for that equation, you could get negative 3, 0, negative 2, 6, negative 1, 4, 0, 0, 1, 0, 2, 10, 3, 3, 3, 36. That would just be from using that equation and plugging in those values. So you would plug in negative 3 for x and solve for y. Remember, this is like it's y. Okay, so the 3 spots where you get a x-intercept, remember that means y equals 0. Well, negative 3, 0, and 1, just like factoring and just like looking at that graph. Okay, so there are lots of ways to be able to solve a polynomial function by factoring, looking at a graph, and seeing the x-intercepts or those zeros, and also from a table of values. Okay. Again, same answers there, so all 3 of those methods are correct. Okay, and then so just kind of a conclusion for this lesson. What can you make about the relationship between the roots of a polynomial equation and x-intercepts of a graph, or zeros of the corresponding polynomial function? So that was like when we factored. Okay, so the roots of a polynomial equation are the same as the x-intercepts of the graph or zeros and the corresponding polynomial function. So they're not going to change regardless if you graph it or if you are finding it by factoring. Okay, So that was your main learning goal there, and you can attempt your homework. Most of these questions, especially at the beginning, are all factoring, so let me know if you have any questions if you don't remember how to factor. Okay, good luck.